NFPA 70, that is, the National Electrical Code, and UL 508A, the standard for industrial control panels, do not have specific requirements that directly address fluid flow in and out of an electrical panel. However, there are sections and paragraphs within these standards that offer general guidance regarding ventilation and the cooling of industrial control panels. Within NFPA 70, Section 450.12 covers general considerations, Section 450.13 addresses ventilation specifically, and Section 450.14 discusses cooling methods. In UL 508A, paragraph 9.23 focuses on ventilation and cooling. Additionally, Annex I in UL 508A provides informative content related to cooling and ventilation calculations. These sections and paragraphs emphasize the importance of designing industrial control panels in such a way that they provide sufficient ventilation and cooling. The goal is to prevent excessive temperatures within the panel that could potentially damage the equipment housed inside or create a fire hazard. It is essential that the chosen method of ventilation and cooling is appropriate for the specific application of the control panel and takes into account the heat-generating components that are present within the panel. Generally speaking, fluid flow in and out of a panel is not considered a primary method for cooling the components inside. However, it may be necessary to incorporate openings in the panels designed to allow for the passage of fluids or gases, especially when dealing with the cooling of transformers or other components that generate significant amounts of heat. When designing these openings, it is crucial to minimize the entry of dust, dirt, and other contaminants that could potentially interfere with the panel's proper operation. The design of ventilation and cooling systems for industrial control panels is crucial to ensure reliable operation and longevity of the enclosed components. Let's delve deeper into the factors to consider and the best practices to implement when designing these systems. Firstly, you need to identify the heat-generating components within the panel. This includes items such as transformers, variable frequency drives or VFD, power supplies, and programmable logic controllers or PLC. Each of these components will have a specific heat dissipation rate, which is typically measured in watts. Secondly, you need to determine the maximum ambient temperature in which the control panel will be operating. This information is crucial as it sets the baseline temperature from which you need to calculate the temperature rise within the panel. Thirdly, calculate the total heat load. Sum up the heat dissipation rates of all the heat-generating components within the panel to determine the total heat load. This value will be used to determine the required cooling capacity. Fourthly, select the cooling method. There are several cooling methods available for industrial control panels, including natural convection, forced air cooling using fans, air conditioners, and heat exchangers. The selection of the appropriate cooling method will depend on the total heat load, the maximum ambient temperature, and the desired internal temperature of the panel. Fifthly, design the ventilation system. If using natural convection or forced air cooling, ensure that the panel has adequate ventilation openings. These openings should be located at the top and bottom of the panel to promote airflow. The size and number of openings will depend on the total heat load and the desired airflow rate. Sixthly, consider using filters. To prevent dust, dirt, and other contaminants from entering the panel, consider using filters on the ventilation openings. These filters should be regularly inspected and cleaned or replaced as needed. Seventhly, use air conditioners for high heat loads. For panels with high heat loads or those operating in high ambient temperatures, air conditioners may be necessary to maintain the desired internal temperature. Select an air conditioner with sufficient cooling capacity to handle the total heat load. Eighthly, implement heat exchangers for harsh environments. Heat exchangers are a good option for panels operating in harsh environments where it is important to keep the internal components isolated from the external environment. Heat exchangers transfer heat from the internal components to an external cooling fluid, such as air or water. Ninthly, monitor the panel temperature. Install temperature sensors inside the panel to monitor the internal temperature. This will allow you to identify potential overheating issues and take corrective action before damage occurs. Tenthly, perform regular maintenance. Regularly inspect and maintain the ventilation and cooling system to ensure that it is operating properly. This includes cleaning or replacing filters, checking fans for proper operation, and inspecting air conditioners and heat exchangers for leaks or other issues. By following these steps, you can design effective ventilation and cooling systems for industrial control panels that will help to ensure reliable operation and longevity of the enclosed components. Now let's consider some specific examples. For a small control panel with a low heat load, natural convection may be sufficient. In this case, ensure that the panel has adequate ventilation openings at the top and bottom. For a larger control panel with a moderate heat load, forced air cooling using fans may be necessary. In this case, select fans with sufficient airflow to remove the heat generated by the components. For a control panel operating in a high ambient temperature, an air conditioner may be required. In this case, select an air conditioner with sufficient cooling capacity to maintain the desired internal temperature. For a control panel operating in a harsh environment, a heat exchanger may be the best option. In this case, select a heat exchanger that is compatible with the external environment and that has sufficient cooling capacity. Furthermore, consider the placement of components within the panel. Arrange heat-generating components in a way that promotes airflow and prevents hotspots. For instance, avoid placing components that are sensitive to heat directly above high heat components. Use baffles or partitions to direct airflow and prevent recirculation of hot air. Also, think about the materials used for the panel enclosure. Metal enclosures, particularly those made of aluminum, can help dissipate heat more effectively than non-metallic enclosures. Consider using thermally conductive gaskets or pads to improve heat transfer between components and the enclosure. Proper cable management can also contribute to effective ventilation. Avoid overcrowding cables, as this can restrict airflow and create hotspots. Use cable trays or ducts to organize and route cables in a way that allows for adequate ventilation. Remember to consult relevant industry standards and guidelines such as UL 500 ATER and NFPA 70 for specific requirements and recommendations regarding ventilation and cooling of industrial control panels, and also perform thermal analysis. Use thermal simulation software to model the heat transfer within the panel and identify potential hotspots. This can help you optimize the design of the ventilation and cooling system. In addition, document your design. Maintain detailed records of the ventilation and cooling system design, including calculations, component specifications, and drawings. This documentation will be helpful for future maintenance and troubleshooting. Always consider redundancy. For critical applications, consider implementing redundant cooling systems to ensure continuous operation in the event of a failure. And train your personnel. Provide training to maintenance personnel on the proper operation and maintenance of the ventilation and cooling system. This will help to ensure that the system is operating effectively and that potential problems are identified and addressed promptly. Moreover, think about energy efficiency. Select energy-efficient cooling components and implement control strategies to minimize energy consumption. For example, use variable speed fans or air conditioners that adjust their cooling output based on the actual heat load. Address noise considerations. Cooling fans and air conditioners can generate noise. Consider using noise-dampening materials or selecting low-noise components to minimize noise pollution. Keep the panel clean. Regularly clean the inside of the panel to remove dust and debris that can obstruct airflow and reduce cooling efficiency. Review and update your design. Periodically review and update the ventilation and cooling system design to ensure that it is still adequate for the current heat load and operating conditions. When designing a ventilation and cooling system, it is also important to consider the specific environment in which the control panel will be operating. For example, if the panel is located in a dusty environment, it will be necessary to use filters to prevent dust from entering the panel and clogging the ventilation openings. If the panel is located in a humid environment, it may be necessary to use a dehumidifier to prevent condensation from forming inside the panel. If the panel is located in a corrosive environment, it will be necessary to use corrosion-resistant materials for the enclosure and components. In addition to the above considerations, it is also important to follow all applicable safety regulations when designing and installing a ventilation and cooling system. This includes ensuring that all electrical connections are properly grounded and that all components are properly rated for the voltage and current they will be carrying. Finally, it is important to remember that ventilation and cooling are not the only factors that can affect the temperature inside a control panel. Other factors, such as the color of the enclosure and the amount of sunlight that the panel is exposed to, can also have an impact. By taking all of these factors into consideration, it is possible to design a ventilation and cooling system that will keep the components inside the control panel at a safe operating temperature and ensure reliable operation. When evaluating cooling options, remember that natural convection relies on the natural movement of air due to temperature differences. Hot air rises, creating a flow that draws cooler air in. This method is simple and cost-effective, but is only suitable for low heat loads. Forced air cooling uses fans to circulate air within the panel, increasing the rate of heat removal. This method is more effective than natural convection, but requires a power source for the fans. Air conditioners provide active cooling by removing heat from the air and dissipating it outside the panel. This method is suitable for high heat loads and can maintain a stable internal temperature. Heat exchangers transfer heat from the internal components to an external cooling fluid, such as air or water. This method is effective for isolating the internal components from the external environment and is often used in harsh environments. When selecting a cooling method, consider the following factors: the total heat load, which is the amount of heat generated by the components within the panel; the maximum ambient temperature, which is the highest temperature that the panel will be exposed to; the desired internal temperature, which is the maximum temperature that the components can safely operate at; the environmental conditions such as dust, humidity, and corrosiveness; the cost of the cooling system, including initial investment and ongoing maintenance. Another important consideration is the ingress protection or IP rating of the enclosure. The IP rating indicates the level of protection that the enclosure provides against the ingress of solid objects and liquids. Choose an enclosure with an IP rating that is appropriate for the environment in which the panel will be operating. For example, if the panel is located in a dusty environment, choose an enclosure with a high IP rating for protection against dust ingress. And if the panel is located in a wet environment, choose an enclosure with a high IP rating for protection against water ingress. Regular inspection and maintenance of the ventilation and cooling system are essential to ensure its continued effectiveness. Inspect the ventilation openings for obstructions and clean them as needed. Check the filters regularly and replace them when they become dirty. Inspect the fans for proper operation and replace them if they are not working properly. Inspect the air conditioners and heat exchangers for leaks and other problems and repair them as needed. And monitor the panel temperature regularly and take corrective action if the temperature exceeds the desired level. The design of industrial control panels needs to consider multiple factors that affect the performance and safety of electrical components. A well-designed panel includes effective ventilation, appropriate cooling methods, and adherence to safety standards. While fluid flow is not explicitly detailed in standards like NFPA 70 and UL 508A, the principles of thermal management are critical for preventing overheating and ensuring reliable operation. By carefully assessing heat loads, selecting suitable cooling solutions, and maintaining the system properly, it's possible to create an environment that protects the electrical components and extends their lifespan. Remember to consult the relevant sections and annexes in NFPA 70 and UL 508 for further guidance on ventilation and cooling practices. These resources provide valuable information to help design effective thermal management systems for industrial control panels. Finally, keep in mind that each application has unique requirements, and a tailored approach is necessary to optimize the ventilation and cooling system for specific conditions. Regularly evaluating the performance of the system and making adjustments as needed will help maintain a safe and efficient operating environment for the electrical components.